All right, Jennifer, thank you so much for being here at San Francisco Java User Group this evening. Um, Take it away.
Okay. Well, you made the comment that we're all adults and we can all be trusted with microphones. I'm not sure I can be trusted with a microphone, but we'll find out.
Okay, folks, we're going to go to our backup presentation for this evening.
All right. Oh, and of course, my presentation jumped under the Zoom bar at the top. Okay. So, we're going to talk about what generative AI means for the Java developer. My name is Jennifer Reif. I know, we'll have questions here throughout the presentation, but if you think of something literally 5 minutes after the presentation ends, or even, weeks, months down the road, feel free to reach out to me. I'm more than happy to talk tech and now generative AI, and Java. So, don't hesitate to do that. Tiny bit of background on me. I am a developer advocate at Neo4j, have been for a few years now. And I really just like to learn technology. So I enjoy technology, I like learning it, and then I like to share what I've learned in a variety of different ways, mostly like events such as this one. I enjoy speaking at events. And then I also like writing technical blogs. So I have that kind of in my hobby time, if you will, if I in the gaps when I can. And then there's a few other things I like to do outside of work, but most of those just boil down to the fact that I'm kind of a geek in a variety of different spheres. So those are always fun. But again, contact information there, and it'll also be on the last slide if you'd like. Okay, so as developers, especially with this kind of wave of generative AI, we're hit with a ton of new terminology and acronyms, and sometimes that can be a little bit overwhelming, and it's hard to weed out and determine what's actually pertinent to my role or to my projects, and what isn't, and how can I utilize this in my daily life. So I just went out and grabbed the general definition provided by Wikipedia of generative artificial intelligence. And it's an artificial intelligence that's capable of generating text, images, or other data using generative models, often in response to a prompt, so some sort of input. Generative AI models learn patterns and structure of the input as training data and then generate new data that has similar characteristics. So you're still dealing with basically what we have been for years, right? Computers take input, they give us output. But now it's able to train itself on the data that we've given it as input and that it already has as input. And it's able to generate new data based on what it has seen previously, and what it's basically going to be using as predictive or probabilistic stuff, which we'll talk a little bit here shortly. So really the core and the crux of generative AI is the LLM, or the large language model. Just kind of a general starting point for that. LLMs use and are based on a lot of data. It's going to give answers based on probabilities, so it's very probabilistic. It's going to surface the highest ranking results. The training is going to take a lot of hardware, a lot of money, and a lot of time. You have a variety of different models, but almost all of those are provided by large companies, such as Microsoft and others, as well as well-funded projects and so on. So you're going to need a lot of funding and a lot of backing and a lot of support in order to build your own model. Not very many of those. Now, this is where here entered the stage ChatGPT. This was released by OpenAI to the public in November of 2022. And what that stands for, ChatGPT stands for, is Chat Generative Pre-trained Transformer. So again, you're dealing with a chat interface, but it's still generating new content. It's going to give you natural language responses based on predicting the next word that it's seen in all of its examples it's been trained on previously. It uses feedback and reward to rank the different responses so that it can learn and basically improve the responses for the next time around that somebody asks a question. And this kind of took the world by storm. It was used, and it still is being used, in a variety of professional and personal, and just anybody and everybody is getting access to this and utilizing it. So that was kind of the foundation. But is it really all that? Is it worth the hype? So LLMs are really good with general information, anything that's public domain knowledge, which is data that it's been trained on, right? It basically kind of, crawled the internet and used all available public sources of data to be trained. So good at historical data. It pulls historical information very well. That's well documented, right? It even does pretty well with creative and artistic ventures, and we'll talk a little bit more about some problems with that here shortly. But again, it's generating new stuff based on things it already knows, so it can kind of create and artistically add things that are relatively good. It's very good at being a human assistant, as computers have been since their inception, and very good with things like task delegation, processing, automation, things like that. So those things it handles very well. Now, the downsides to an LLM is it's going to lack very, very recent data. So again, LLMs take a lot of money, hardware, and time to build and to run. And so they have some sort of information cut off to train the model. So you're going to not see real time, very recent information there. You're not always going to get a natural language response. There's certain language complexities and things that it doesn't handle very well. Things like sarcasm and emotion, it has not mastered, at least not yet. So, or not there, but it does pretty well at handling natural language. But there's certain things that it doesn't completely comprehend or understand all the context behind yet. It also doesn't provide sources at this point. So it'll provide an answer and list information very, very well, but it doesn't give you the source of where it got that or how it got to that answer. This is where things like hallucinations kind of come into play. Again, a little bit of that artistic and creative license that it takes. If it doesn't know an answer, sometimes it'll just kind of make up an answer. And it sounds very logical. It sounds very real and factual. But when you actually go back and do the digging, it's not at all. It's completely made up. You can control a little bit of this by setting an LLM temperature for how factual or how creative you want it to be. But again, this is kind of an imperfect art, if you will. There's also problems with intellectual property. We talked again about the creative and artistic angle of LLMs. But then, of course, all the data that it's been trained on, mostly people have created that, right? So then you're kind of encroaching on intellectual property of creations that other people have made. There's some bias things that are still being kind of looked into and researched and tried to improve there for trying to reduce that. And then also user privacy and just information privacy in general, because again, the model is taking and soaking up all that data. Okay, so how do we improve the LLM accuracy? We've talked a little bit about that, and that's at least the biggest issue right now at this point in time. So there's a few different approaches to that. You can build your own custom model, but again, we talked that's very expensive, very time consuming. So not the most approachable option out there. You can do something like fine tuning, which is taking a lot of data and basically tuning and adding that to the model so that it kind of learns and ranks those responses a little bit better. You can also do something called few shot learning, which is just a very few high quality pieces of information to help train the model. Again, fine tuning is a little bit more excessive than building your own, but it's still quite labor intensive and resource intensive. Few shot learning is again going to be a little bit even more approachable, but again, it needs a little bit of kind of expertise in order to do that well. So kind of the baseline for what everybody's going to is this thing called retrieval augmented generation, or RAG. So you hear this term all over the place. What does this actually mean? I like to think of RAG as pulling data for an LLM from any external data source. Typically, you're going to see that as a database, but it can be anything. It can be a trusted website. It could be a source file somewhere or a hosted, set of information. But you'll typically see that data being pulled from a database. So retrieval is going to retrieve that information from some type of data source. You're going to augment the response by using facts you've pulled from that data source, that valid factual thing that you've verified as good information, right? And then you're going to use the generation component, which is going to use the LLM to provide the response in natural language from that information that you've given it. So you can kind of see this diagram on the right-hand side. You have this user that asks a question or provides some sort of prompt or input. That's going to send to the LLM. It's going to do a database search, look for the relevant information that it can find in the database. It's going to retrieve that, send that back up to the LLM, and the LLM is going to take all that information and generate a response for that. So again, what you hope is going to come out of this. Why would we even use this approach? It sounds kind of cumbersome, right? You're adding a lot of extra steps. You have now, data integrations and data store connectors and things like that. But what we hope is that we're going to be able to get to a point of explainable AI, which is using retrieval augmented generation and the capabilities of a large language model, and find out how the LLM got to this answer. Where did it get this information? How did it arrive at this point? And so you'll hear this term of grounding an LLM or grounding the information or the answer. And this is what we mean by this is we're grounding that answer, the LLM's information, with verified data so that you get a better response and you're less likely to hallucinate. Now, typically, when you look at retrieval augmented generation and an LLM, you'll use some sort of vector database. That's kind of been the tradition in the last couple of years, and something that has kind of taken off. So, first off, what is a vector? And then let's add that into the conversation of the database space, right? So, first up, the vector. A vector is just a length, a direction, and those components are going to have meaning. So, it's basically like a line. Think back to mathematics, right? What this allows you to do is start comparing things that you can characterize the different features into a number representation. So, for instance, that first kind of arrow or trajectory you see there, we have things that are not very long, but very wide. So, blocks that are tall, right? The second one, you have things that are very long, but not very wide. So more, kind of long-shaped rectangular. And then at the bottom on that last vector, we have things that are very long, but very little width at all. So very short, if you will. And so then we can start characterizing and getting a feel for what's similar, in this case, based on kind of length and width, right? And sizing and all of that. But this allows you to do cool things like vector arithmetic. So you have kind of this point in space. I can say, okay, I have A, I have B. Can I determine the length of C? And most of us would be like, yeah, that's a simple mathematical equation. No big deal. We've done this, forever, so many years, right? But what if we apply this to words? So if we could take everything that represents the word for king, so all the characteristics and features of the word for king, and we have that same kind of vector representation for man and for woman, we have our understanding of the word king. We could subtract the vector for man, add the vector for woman, and that's going to give us a vector that should be equal or pretty close to the vector for queen. So again, we're able to take our understanding of concepts in a numerical representation and learn new concepts based on how they're related to the old. So, okay, how do I actually do this? How do I convert words into sets of numbers, right? That sounds really complicated. You're converting that data to a point in space. It's going to be a series of numbers. That's what a vector is. And you'll have hundreds or even thousands of dimensions. And dimensions are just interesting features or characteristics that it deems kind of important. So you'll take everything that the term king means. So things like, male and ruler and maybe kind of leader or so on. And all of those features are going to get characterized and boiled down to a set of numbers. And then you can start comparing and adding and subtracting, if you will. And you'll see embeddings for things like audio, text, video, images, and so on. So you can pretty much create an embedding from almost anything. Okay, this is cool. But now what do I do with that, right? You can start running things as we kind of talked about, learning old concepts, or learning new concepts based on old concepts. We could do things like similarity search. And we have these vectors, these number representations of information. Now we could do, okay, what are the similar things? Or I know this concept, what's close to it, right? However, even if you just take our example of vectorizing words, if we took all the words in the English language and then maybe we even broaden that out to all the languages in the world, that's a lot of vectors. Having to query and say, okay, I have the vector for king, what's similar to it? And comparing it to every other word in the English language and then every other word at a global scale gets really, really expensive, right? So you can use something, an algorithm called approximate nearest neighbors, or KANN. The K is the number, so 10 closest vectors, 50 closest vectors, etc. And it'll kind of retrieve kind of an estimate or kind of best estimate, if you will, of the closest things to that. So let's take an example. In a library, you'll typically classify or organize books by author or by subject or some other type of classification system, right? But by using vectors, we could actually take each one of the features that we've vectorized. So say, for instance, location of plot, and we could reclassify the entire library based on the location of the plot. So now everything that has a location of San Francisco, that your books have a location of San Francisco, now all of a sudden they're all right there in that nice, neat little line, and you can pick out exactly what you want. That's going to give you a much smaller search set than by author or by category, by genre. And so that's going to give you much smaller retrieval time as well. So make finding things much faster. Okay, now how do we choose a database? Because again, we've talked a little bit about, vector databases kind of often the go-to. What do we get with that? What's the good and the bad there?
मी ऍड बघितली तेव्हा मी बघितली.
Pinecone is really the kind of highlight database that has been, I'd say, made most popular in this space. It's not the first, but definitely kind of took the world by storm. The pros here is vector databases are going to have very fast retrieval of highly dimensional data. So we talked about embeddings having multi-dimensions or features or characteristics, right, that are represented in that number. It's going to allow retrieval of that stuff to be very fast. You can run similarity searches based on the vectors, not on specific values. So if you think about a traditional database, you would look for a book plot location of San Francisco, or you'd look for an author of this, and even fuzzy searches and stuff. You're not very broad at that point. You're looking kind of for a specific value. The vector databases are not going to do that. Again, you're going to take all those features and find out what's similar based on all of those features and not just one set. The downside here, you're going to need a lot of infrastructure and power, and it doesn't really store a whole lot outside of the vector and some metadata. So you're going to get a little bit of extra information and context there, but maybe not a ton. Graph databases, Neo4j was kind of one of the first entries to the market in 2007, but there's lots of others out there as well. The good sides with a graph database is you're going to have a very flexible and agile data model. So as the business changes, your model can be flexible and respond to that. The biggest thing is it's going to store the relationships alongside the entities. So it's kind of like a visual or a written join, if you will, to the database. The downside of this is you are going to have a little bit of write overhead when you actually store those relationships. And you're not going to see really any benefit when you have very low connected data. So something that's very tabular, not very many joins or not a whole lot of connections, you won't see much benefit there. But you get a lot of benefit when you look at the relationships stored there. So how does this help me in GenAI? How are graphs a good thing? You'll hear this term of knowledge graph as kind of a subset of graphs in general in GenAI. The good things with this here is you can generate an LLM response from the knowledge found in the database. You could set security rules in the database for what's viewable, what's personal identifying information, what's accessible and what's not, and so on. You can store structured and unstructured data side by side. Your vector databases are mostly going to store unstructured data. Again, you can have a little bit of metadata and some other things involved there, but it's going to lean toward the unstructured side there. And then a graph is going to help you retrieve those connected entities. The connected information is going to give you that extra and the relevant context to pull in alongside just the vector search. So you kind of see this diagram I have in the corner. We have just the vector search or vector database, if you want to think of it like that, for finding just similar documents. You can use, separately a graph database, which is going to do basically pattern matching for queries to pull related information. But when you combine those two things, those two powerful concepts, using both vector search and pulling relationships from the graph, you get this idea of a knowledge graph, which is going to combine those two things for accurate results within a very relevant context. Okay, now, caveat here, nothing's going to be a silver bullet. The LLM is still kind of a mind of its own. So you're not going to be completely definitive and consistent. So it'll still generate some odd things here and there. You'll have to do some prompt engineering if you're using prompts. So you'll have to kind of course it and guide it into the right type of response. And you may run up against some problems with context window limits, which is just basically the size of the input that the LLM can take and evaluate, right? So if you have a massive amount of information that you're trying to pass into the LLM, sometimes it will only take so much. So you can run into that issue too. Okay, so before I dive right into the demo and live coding portion, just a little bit of context and backstory on this. So this is the data model that we're working with. I've got the data already in Neo4j, and this is kind of the data model that we're dealing with. So in the purple, we see we have books. I've pulled a book Goodreads data set. And then we have reviews that were written for those books. And then we also have users publish those reviews and authors who authored those books. We're really going to focus in today on just the review and the book. So we have review text that somebody, a user has written a review and they've included all the information that they like and dislike about this book or that book, right? And so we've taken that text and we've generated an embedding rendition of that. We've stored it on the review. And then what we're going to do is we're going to write an application that's going to look for similar books based on a phrase that we could find in reviews. And again, it'll do a similarity search, and I'll show an example of that rather than a specific value search. But we might look for something like, a fairy tale book, and it would find all the reviews that have something similar, that general conceptual model of fairy tale, and it'll then go out to the graph and retrieve all the books that are related to those reviews. Okay, let's dive in and do my favorite piece, which is the live coding. Okay, so first off, what I want to start with is I'm going to use Maven. I'm using Spring initializer here, so the Spring kind of ecosystem, if you will. These concepts and this kind of general structure will translate across other models, other languages, and so on, other frameworks. But I just happen to be using Spring tonight, so we'll stick with that. So we have our language in Java, of course, and I'm going to stick with the stable version of Spring Boot. I'm going to change that, and we're going to call this sfjug demo. And we'll stick with those. And then let's add some dependencies. So the first thing I want to do is I'm going to create a REST API. So I'm going to include Spring Web. Now, I also want to pull in the AI, which they just actually added this to the Spring initializer. So if you've not been out there in the last couple of days, this is new. Previously, you had to kind of enter all these dependencies in on your own. So that's not the case now. So I'm going to pull in OpenAI. Again, lots of other types of models you could use, LLM models. We're just going to be using OpenAI for tonight. And then I want to pull in a couple of Neo4j things. So first, Spring Data Neo4j. This is going to allow me to connect to Neo4j database, run queries against it, and so on using the data access libraries that Spring provides. And then the Neo4j vector database as well. So when we want to use it as a vector search and do the vector similarity search in Neo4j. And so we need to add that dependency there too. Okay. Now we're going to generate this project, drop it into downloads, and hopefully we will be off and running here. So switch over to terminal. Okay. Oh, yep, that's right. I haven't. Silly me. I didn't unzip the archive folder there. So 1 second. Okay, now we should, there we go. Okay. So
if you wouldn't mind making your terminal font window just a teensy bit zoom in or larger, that would be amazing. Awesome.
Yeah.
Thank you.
Yep, no problem. And then open the pom.xml. And that should open IntelliJ for me. And I already tweaked the IntelliJ settings. So hopefully it should be. Oh, I'm going to have to draw this screen out and move this one over because it didn't remember I need it on the screen. There we go. Okay. All right. Okay, so hopefully everybody can read that okay.
Yep, looks great.
Awesome. Okay, so I always like to check the POM just to make sure everything came in okay. So we have our data Neo4j library. We have our web dependency. We have the AI Neo4j store. So that's the vector store piece. And then we have our OpenAI starter as well. And it pulls in the Spring AI version and all that good stuff as well. So that's all there for us. Now, normally I would hop out to resources and show how you would use the properties to pull in to access Neo4j and hook up to a database and to put in your OpenAI API key. However, I've set those in my environment instead of the application. So if you want to know what those properties look like, go to the GitHub repo that I'll show at the end and you can see those. But I've just gone ahead and set them ahead of time in my environment so I don't have to provide those secrets here. Okay, so let's start off first with a couple of things. We need a couple of Spring Beans, which is going to have dependencies that we can then inject across all the classes where we need them. The first thing I want is a driver. So I need a Neo4j driver. And we're going to return a graph database dot driver. And then since I have these set in my environment, I can actually just access this. There we go. Get env and spring neo4j URI. Okay. And then auth tokens dot basic. And again, system dot get env and spring neo4j authentication username. And then same thing, but for password now. Spring neo4j authentication password. Okay, that should set that up. And the next thing we need is our embedding client. So this is so that we can connect to the LLM and run stuff there. So return new OpenAI client, and then we need a new OpenAI API, and this is where we're going to call the system.getenv, and we have our Spring AI OpenAI API key. That is really, really hard to remember. Okay.
Yeah.
So
Ooh, a lot of AI in there.
Yes, it is. Lots of like, okay, where's the underscore?
Doop, de doop, de doop, de doop.
Yeah, lots of typing there. All right, so the last thing we need is a Neo4j vector store. So we're just going to call this vector store, and we need to pass in our driver so that we can connect to the database, and we need to pull in our embedding client so that we can connect to the LLM. And then we're going to return a new Neo4j vector store. We're going to pass in the driver, the embedding client, and then we also need to do a Neo4j config. But we're not going to use the default config. I will tell you why, because Spring AI expects an object or entity of document to run the embedding stuff on. And when you don't have that label in the database, then you have to tell it to build with a different label, a custom label. So again, we're taking the review text and we're creating the embedding off of that. And then we can build that. And that should take care of all of our dependency stuff that we can inject. And we will actually be injecting those here shortly. So, all right. The next thing we can start doing is putting in our application domain. So I'm going to generate a record to kind of shortcut some things, a little bit less boilerplate. So we have an ID, string ID, and then we have a string title. Or no, this is review, sorry, text. And then we have an integer for the rating. So we're going to store those three properties for review. Now let's head back and add our book entity record. So we have, again, an ID. We're going to have a string book ID. We have a string title. We have a string ISBN, and then we have a string ISBN 13. And then last but not least, we need to tie these two entities together using an at relationship annotation. And then the type of the relationship, we have that written for. So remember, a review is written for a book. And then I also need to specify a direction. I didn't call this out when we were looking at the data model image in my slides, but A review is written for a book, which means the direction of the arrow is going to book, which means it is incoming. So I have to note that. So we're going to have a list of reviews here. And then we're going to call this review list. Okay. That should set that up nicely. Now we need to actually do the interface to make the database access calls. So where we set up our queries and so on. So I'm going to create an interface. I'm going to call this book repository. And we're going to extend the Neo4j repository. We have an entity type of book and the ID type of string. And we're going to go ahead and create our query in here. So we use a query annotation. And here we can write, using Spring Data Neo4j, we can write cipher queries in order to access Neo4j, since that's the query language it runs off of. So if you remember right, we have reviews, review text that we've got the embedding for. We're going to do a vector similarity search that's going to retrieve reviews that are similar to that search phrase. But then we want to go out to the graph with those reviews and say, okay, pull the related books. So we're going to be looking for books. And we have the relationship written for, and then we have the review on the other end.
This is so why I came here tonight. I haven't really been thinking about like how do you apply the graph model to this whole domain. So this is just awesome. Great.
Thanks. Yeah, this is my favorite piece of writing the cipher queries, honestly. But and we're going to pass in those review IDs. So we have a review ID in a set of review IDs we're going to pass in. So review IDs like that, and then return the book. And then we're going to collect the relationships and the related reviews into lists. That just ensures we get unique records back for each book. And then we can have an iterable of books that are going to be here. And we're going to call this find books. And we're going to pass in the list of strings. That's going to be those review IDs. And we'll plug this in just a second. Oops. This will make a lot more sense in just a minute. Okay. So now we're going to add our controller. So this is where we're going to put the endpoints, the REST API endpoints, in order for us to connect and ping and see stuff. So this is where the rubber is going to meet the road here. We have our REST controller. We have our request mapping, and we're going to just put an endpoint of / for now. Then we need to inject some things. Remember, I told you we would come back and inject those beans that we created at the beginning. So this is where we're going to do that. First off, we need to create an OpenAI chat client so that we can chat with our LLM, right? We also need to inject our Neo4j vector store so that we can access that. And don't worry about the red lines under anything. We'll fix that in just a second. And then last but not least, we need our book repository. And we're just going to call this repo. Now it's telling me, hey, you need to generate a constructor. You're not injecting that into a constructor. So there we go. We made it happy. Okay, now we need an endpoint in order to put this all together. So I'm just going to create an endpoint called /rag for now. And we're going to be returning a string because that is what the LLM response is going to be. And then let's just call this get generated response with context. And we're going to pass in a request param. We're going to call this string search phrase. So again, we're going to pass in a search phrase that somebody's looking for, and we're going to return related books or recommendations of books, if you will, for that. Okay, now the first thing we want to do is that vector similarity search, right? So we need to pull the related results from the database. So we're going to have a list of documents. Now, remember I said that there's the AI, there it is, that Spring AI is looking for an object or entity type of document. And so if you don't have that in your database, it will take care of the mapping for you. But again, it's going to expect that document to come back. So we're just going to call this results. We're going to call our vector store and run a similarity search. We'll pass in a search request with a query, and we're going to put in that search phrase. And then we also want to do just a couple of things here. We're going to pull the top 5 results. The default is set to 4, but I kind of like, the top 5 for book recommendations, right? That just seems like a better number than 4. And then with a similarity threshold. So here is where you can kind of set how similar a result you want to pull. If it's too far off the mark, I don't want to return it. And there's some interesting information out there with some bad data and things that are in the database, which of course we would curate and fix. But for the demo, we won't mess with that. But what I want to set is, okay, anything that's less than an 80% similarity, I'm just not even going to retrieve it. So hopefully that'll get us some good results there. Okay. Actually, we need an iterable here because this is where now we've retrieved our similar results based on vector, but now we need to go back out to the graph and retrieve those related books from those reviews, right? So we have an iterable of book, and we're going to call this book list, and we're going to call our repo.findBooks, and we're going to pass in the results that we got back from the vector search. But pardon this little bit of ugly mess, because remember, we have a list of documents for those results, and we would want to just pass in the IDs. There's no reason to send the whole document or all that information over. So we're going to stream all those. We're going to map each document's ID, and then we're going to collect those to a list. So yeah, kind of not super pretty, but it works. All right, last but not least, we need to set up our prompt template. So we're going to call this template. We're going to say new prompt template, and we're going to pass in, oops, I almost forgot. I can set up a string prompt up here so that I can just pass it in. And because nobody wants to see me write just a bunch of text, I had a, whoops, come on. I just have a little bit of a cheat sheet here to kind of just copy in the prompt. So you're a book expert with high quality book information provided in this context section. And you'll notice we have 2 kind of parameters here that we need to fill. So let's do that. We're going to pass in our prompt first off, and then we need to do a map.of, and I'll go ahead and put a semicolon here so it's happier. And then we need to fill in those parameters. So we have the context parameter, and we're going to fill that with the book list that we just pulled from our database. And then we also have our search phrase parameter, which we'll fill with our search phrase that's coming in. Okay, now one thing I like to do, just so we can see the output and verify the responses, is to print this out. And then same thing here.
2024, and we're still at system.out.println, folks. That's right.
Yeah, sometimes it's just easier.
I'm just giving you a hard time.
Yeah, no worries. Okay, so then we need to return. We're going to do a client.call. So remember, our client up here is this OpenAI AI chat client. So we're going to call that client. We're going to call it, and for lack of a better term, and we're going to provide a message. So in this case, we're going to take our prompt template, and we're going to create a message based on that prompt template. And then I just want to get the string, the result, the answer, the contents in this case, back from that. So we have our nice little happy string value being returned. And we just want to see the results of the LLM call anyway. Okay. Now, if I have done enough to the demo gods and set everything up properly, this should run. We'll find out. Okay, so we're going to do a Maven W spring root run.
I think the good Bob Ross imitation there just a minute ago will appease the demo gods.
Hopefully.
Just want to give you a quick time check. You're at about 7:20.
Okay. All right. So this is looking good. I'm going to pull up a new tab, and this is where it all comes together, because hopefully we'll see some good results when we call this. So I'm going to use HTTP. You can use regular curl, but this actually is pretty nice, and it kind of makes things a little bit easier in certain respects. So we have our endpoint of RAG /RAG, and then we need to provide the search phrase. And we could provide a lot of different things for the search phrase, but let's just look for something that has maybe something similar to a happy ending. And yes, I've encoded the space with %20 there for anybody who's catching that. Okay. So books with a happy ending are these two. Okay, that's great and all. Where's the context, right? So let's go back to our other tab. And here's the actual prompt. This is why I did the lovely system.out.println, because now we can see, okay, here are the books. We have our undivided, and here's the review. Okay, great ending. So similar to happy ending, maybe, maybe not as much. We have this one here. So that actually this undivided wasn't even provided in the results set, was it? No, it was not. Okay, so that's why. Not super relevant, maybe. Pulled in the vector search, but apparently the LLM has decided, not super close. So touching ending, again, not super close to happy ending. Okay, here's the title that was provided. The review is beautiful, happy ending. Great. That looks nice. Okay, and here's the other one. And the review for this one says literally happy ending. Okay. Okay, and this one actually has over here says weak ending. So it's a good thing that one wasn't provided, right? That would have been an ugly shock for somebody. All right, let's do one more here. And hopefully we will see if the LLM behaves, how it does not do necessarily a keyword value search. It's going to do a vector search. Let's see what we get when we look for books that have something about encouragement in them. Okay, so it's going to provide five results here. So all of these, let's take a quick stock. So Cross and Switchblade, this 90 Minutes in Heaven, The Greatest Gift, Art of Recklessness, and this Aligned, Volume 1. Okay, let's go back to our context.
This is so cool.
And see what we actually get. So Cross on the Switchblade, and the review text says encouraging. So encouragement, encouraging, very close. 90 Minutes in Heaven. Okay, what do we have? Inspiring and hope-filled. So there, it did not do a keyword search because there's encouragement is nowhere in this text. But when you think of encouragement, inspiring, hope-filled, those are kind of synonyms, right? So again, it's pulling that vector search, similar results that have that kind of similar meaning. The Greatest Gift, similar to Wonderful Life. There it is again, inspiring. So similar to encouragement. The Art of Recklessness. This one says great insight, great encouragement, great company. And then this Aligned is going to pull healing. Now, again, if you think of encouragement, sometimes that does coincide with some healing or kind of positive thoughts, if you will, going along with that. So this even is, again, not pulling a keyword search, just something that's contextually related there. Okay, so we see those results. We're seeing the information influencing the LLM and pulling better results. Which by the way, the full demo actually does have, just an LLM call and just the vector search call so that you can see kind of those differences. But the LLM's response doesn't retrieve any of that context. You have no idea where it's getting the information from or how it's coming up with those results. So super valuable to kind of ground that LLM's response and verify that information is actually what you're looking for and is relevant. Okay. So last but not least, resources for tonight. The code that we ran today, as well as some extra stuff that I kind of hinted at, is all available in that first repository. So if you're looking for just kind of an overview of calling an LLM versus doing a vector search versus adding the component of RAG, retrieval augmented generation, you can find all that information in the repository. We also have on Neo4j, if you want to learn a little bit more about how Neo4j and LLMs work together, check out our free online self-paced courses at Graph Academy. That's in that second link. There's 2 available right now, but there's more soon to be coming out. Really excellent content there. I've taken a couple of them and they're really, really good. The final one is if you want to learn more about Spring AI, the link here I've included is for the Neo4j as a vector store for Spring AI, but they have the full list of vector stores that they support, as well as just general information about Spring AI that you can find in that documentation as well. So again, contact information is there. I'll stick around and answer some questions and thank you guys so much for being a great audience.
Unbelievable. Let's hear it for Jennifer, folks. I clearly should have massive oversight. Should have been having you on here months and months and maybe even years ago. Really great presentation. This is awesome.
Yeah.
Personally, I just have to say I've been wondering what the intersection with graph, because that is not my I have not spent a lot of time with graph databases. I don't know if I'm alone on that one, but I've been really curious because I know. Yeah, I've been curious how it applies, right?
Yeah.
Especially with vector, and you really pulled these two together. Incredible. Yeah.
Thank you.
What power to like see, yeah, not just string matching, not just dumb string matching,
Yeah.
semantic matching. Like how cool is that?
Yeah. It's
That's
very cool.
that's that's where this stuff just really shines. This is amazing.
Yeah.
Um, Very cool. Thank you for putting up with my heckling. A gentleman named Udit made a comment earlier about 10 minutes ago about maybe writing type safe queries rather than a string query. I'm not 100% sure what he was referring to because it drove by me, but maybe you know. But no questions as of yet, folks. This is a great time to ask questions of
Yeah.
Jennifer before we get started with Brian's presentation, and we have one. Geff is curious if I've understood things correctly, when these LLMs and AI were being developed, nobody thought to include some kind of provenance with the output to explain how it was arrived at. Yeah. Oh, nailed it, buddy. Yeah, right on. Nailed it. Yep.
Yeah.
Yep.
Some of this, there's a really good quote from Jurassic Park that is kind of circulated around with this kind of stuff, and it's the scientists, wanted to find out if they could, but they never evaluated the fact of whether they should or
They
not.
should.
And so I think there has been some things that maybe it was just oversight. It's like, well, let's see if we can even build something like this. Let's see if it even works, kind of thing. And now they're having to kind of go back and add some of these safeguards and a little bit more information and detail and stuff. And again, every model that gets released is improving and getting better. And maybe RAG at some point will go away. But at this point in time, at least, having that good, solid, quality information is a little bit difficult to get with an LLM.
Yep. Definitely. And I mean, developers don't understand rushing something to market without considering the implications, right?
Never.
Right. Too soon. Too soon. Okay. Um, good comment from Julie. Not even the experts can explain what's happening inside a deep neural network. Amen. Yep. Yes, absolutely, Julie. Nailed it. So folks, if you have and you're getting a couple compliments on great demo and a couple little happy emojis. Yay. We love the emojis. I personally have to commend you on the Bob Ross segment of your demo there a few minutes ago when there was like some happy little curly braces, I think. But all right. And then a comment from Sean. Bing Copilot produces answers with footnotes linking to web pages. Yes. Presumably combining web search with a database. Yeah.
Yeah.
A comment from COVID, spelled with a K, not a C. When we say RAG or retrieval augmented generation going away, can you please help explain in which context? Great demo. Thank you.
Yeah. So it's not going away, I don't think, anytime soon.
Right.
But as LLMs improve and as people start looking for, hey, I need the sources of this information to verify how good of a response this is, that's going to become increasingly important. We want that explainable AI. How did this LLM get to this answer? Why did it end up here? And right now, LLMs don't do that. They don't provide that context. And so that's where something like retrieval augmented generation or RAG comes into play, where you need that data source to provide that backstory and the context and the detail that an LLM can't at this point in time. However, as they continue to add training data and kind of fine tune those models, hopefully we will start seeing that improve, and you'll start seeing, source links of here's where I got this answer, or here's, some sources you can follow up on this answer or something like that. And as mentioned with, I think somebody said, was it, what chat was it you just mentioned, that they're starting to provide some footnotes and sources to some things. So it's starting to become important. I think people have spoken up enough that this is increasingly important, that I think you'll start seeing that more. But how long it's going to take to get there, who knows? And then there will be some things like private information, or sensitive information, or just even personal, preferences and things like that you don't want public. You'll still need to have that in a database somewhere, because you don't want to put that on a public source for the
Exactly.
LLM to pick up.
Exactly.
So you're still going to need that data backend somewhere in order for the LLM to respond and have those personalized responses that you need.
All right, folks. So we have a couple more questions, but in fairness to Brian, I want to make sure he has time to present. Also, Jennifer, maybe what we can do is engage on the chat panel
Yep.
with some folks. You're welcome,
Happily.
COVID. You're welcome, COVID. No problem. let's engage with on the chat panel to follow up. There's been a pretty lively chat throughout the meeting. And oh boy, I'm not going to say the name right, but there's a good question for you there to dig in from Mega on private LLMs. But yeah, anyway. So with that, please, folks, continue typing in your questions for Jennifer. This is a really awesome session. So I think what we're going to do is we're just going to extend it a little bit so that Brian has the full time to present his content. I know we ran a little bit over. Brian, my apologies. Partially my fault. And we are just warming up here because Brian is awesome and he is about to bring it. So do not change this channel. Let's talk a little bit and see what Brian tell us a little bit about what's going on at Microsoft, the people that are printing money with OpenAI. How's things going on over there in Azure land?
Things are good. Things are good. Yeah, no, thank you, Jennifer. That was amazing. I love to see the Spring demo and the live coding was fantastic. I'll cover a couple of other things that aren't Spring in a little project called LangChain for J. But before we get there, I just want to add to the conversation about what we are working with here. Now, Jennifer very capably demonstrated that she has deep knowledge of how this stuff works. But whenever I work with this stuff, I'm always reminded of an old movie called Morons from Outer Space. I don't know if anyone remembers this movie. Or if you don't, look it up, check it out. It's still on VCR probably or something. It's an old movie. But one of the things I loved about it was these aliens come to Earth. And they're in like an old Winnebago, an old RV. And they get taken in for questioning by the government. It's a British movie, by the way. So it's a British government. They take them in for questioning and they're saying, how does your spaceship work? And they go, we already told you. You press on the right pedal and it goes, and you press on the left pedal and it stops. And that's kind of, I think, where we're at with OpenAI and AI tools in general, large language models. Is kind of, we just know how to drive them, but if anyone does, there's only a few people who know how they actually work at a deep level of understanding. So it's kind of interesting to see what's happening right now. Anyway, let's dive in. So I'm going to show mostly demos, but I do have a few slides. My name's, by the way, I guess I should introduce myself. Brian Benz, Cloud Advocate at Microsoft.
Yeah, why not?
Yeah. Why not? I'm a cloud advocate at Microsoft. I've been there about 11 years. I joined Microsoft way back in the day to cover Java at Microsoft, which was an interesting experience back then. It's changed a little since then, and we do have Java all over the place now. I'm not going to be talking about that, but I did want to talk to you about JDConf. JDConf's coming up quick. A little plug here. March 27th to 28th. You can RSVP at jdconf.com. It's a free online virtual conference. We have speakers that you'll know and love from all over the Java landscape, and they'll be covering a lot of interesting topics. And we're going to highlight AI a lot. It's going to be 3 different time zones. We have 3 different broadcasts happening across the world. So check that out. Anyway, jdconf.com. All right. So I did want to mention, folks at Microsoft. So Peter was mentioning the money printing that we're doing with OpenAI. It's pretty cool. We also have all the things you see on the screen here, including cognitive search. Poor cognitive search now. It's sort of really been eclipsed by OpenAI, but it's one of the ways we handle RAG. So retrieval augmented generation is using cognitive search. We also have some pretty cool things with video indexers. Check out the Azure Video Indexer. It splits out videos and identifies people and landscapes and all kinds of stuff in there. And we have vision, speech. The speech one is really cool. I use it quite often when I travel overseas. Bing Translator, I know Bing, but it's really, really good. You can set it down on the table on your phone, and you can just talk to anyone in any language, and it automatically detects the language and translates it for you. It's pretty cool. Anyway, I don't want to dwell on too much of this. I'm not here to sell this stuff, but it is a pretty comprehensive platform that we have there. Azure AI Studio, I'm going to show you a little bit about this. You can build and train your own models. You can ground Azure. As Jennifer mentioned, grounding means you're, creating a data set that is verifiable. And you can ground the OpenAI service, which is accessible through Azure OpenAI APIs, and your open source models using your data. There's vector indexing built in. You can use your choice of vector indexing, MySQL, Postgres. We have a Cosmos DB, which is a multi-model database, including MongoDB and some others. And then RAG is pretty easy with that, and you can create prompt flows. And we do have safety built in. I'm going to show you a demo of that in a little while, how it takes my prompt and rewrites it. And it does give me the changed prompt. It's pretty interesting. You'll see. And then, you can work with your data for OpenAI. It's secure. And, we spend billions on cloud security and compliance every year. And all that benefits our AI offerings as well. All right, so co-pilots, somebody counted them a while ago inside of our group at Microsoft. There's 97 co-pilots at Microsoft right now, doing different things. It's crazy, and they're mostly useful. I took a Markdown document the other day, pasted it into Word, and I said, just, change the Markdown headers to, Word object headers, and it did that. And another one, what else did I do? A couple of things that I've done that are pretty cool. Oh, well, WordPress. I had to write something in WordPress. So I had a Word document. I just said, convert this to WordPress objects in text that I could paste in. It worked. It's just things you don't think about that really saves a ton of time. Security Copilot, I encounter all the time. As a cloud advocate, I write demos. And quite often those demos have security as an afterthought. And we get all kinds of notifications and warnings and exceptions and escalations if we don't fix them when we actually write our demo applications. Even though there's no data or anything that could be hurt, it's pretty amazing to see those things in action. And then last but not least, GitHub Copilot, which I'm going to be covering today. GitHub Copilot, it's probably easier if I just show you how to drive the spaceship rather than describing what it actually does. Basically, there's two parts of it, though, I wanted to mention: Copilot and Copilot Chat. So Copilot is just basically autocomplete. It's an incredible autocomplete, though. Good and bad. I was just running through my demos earlier, and autocomplete kept putting the OpenAI API key into automatically, helpfully adding that to my code, which is not great when you're doing a live demo, by the way. And then we have Copilot Chat, which is something that I'll show you. It's just basically interactive chat, similar to what you're familiar with ChatGPT, but it's trained on all kinds of code. VS Code is what I'm going to show you today, but there are other things you can use Copilot and Copilot Chat with, including Visual or GitHub Codespaces, Visual Studio, if you're so inclined, JetBrains IDEs, and NeoVim. That one is often forgotten, but GitHub Codespaces is really cool. You can fire up something on the web. It has a built-in IDE, and it has all the extensions and capabilities that you need. So how does it work? Basically, there's context that gets revealed when you're working with code. So beyond the regular old ChatGPT, it knows what file you have open. It knows where your cursor is. It knows if you've highlighted something. It knows if there's anything it needs to know inside of your context. You can feed it information just by having things open, for example, and it will use those as part of the answer that you're asking. So file names, as I mentioned, open files, cursors, and whatever you've got selected. And then there's inline completions, so you can do special keys to accept or check for a new answer if you don't like the one it gave you. And you can accept word by word, and you can do also a couple of other things. All right, that's enough of that. I'll talk about responsible AI journey because the lawyers like me to do that when we get done with the demo. How's that? So this is the Azure portal. And what I've done today is I've created an instance of Azure OpenAI. And for those of you not familiar with the Azure portal, portal.azure.com, You can get a free account if you want, but this is a resource group with a whole bunch of things. I'm going to show some of them today. And I've got a bunch of links here on the right that I'm going to be referring back to all the time. But for this one, let's go to AI. So what we've got here, when I want to create a new AI instance, AI for Java, this accesses OpenAI, which is the same thing you use for ChatGPT. It's got keys and endpoints. So basically, whenever I set something up, it gives me a couple of keys and an endpoint, and there's different regions you set this up with. And once you've done that, you deploy models. And I can show you the models I've got deployed. So let's see here. There's deployments, don't worry. It says no deployments found. There. Okay, so it's a good little adrenaline rush every time you see that little screen when you're doing a presentation, especially. So I've got two deployments here. GPT-35 Turbo 16K. What does that mean? Well, it's using GPT-35 3.5, and you can use 16K of prompt when you paste things in. And then I've got DALL-E 3, which is the latest image generator. And I'm going to show you both of those things. But if I want to create a new deployment, I could do that. I can select a model. DALL-E 3, I've got Turbo, I've got 3.5 Turbo 16K and Turbo Instruct. I've got GPT-4. And then there's a couple of text embedding models as well. Those can be used for various purposes. I'll go into all the details there, but the other one I've got is DALL-E 3, which is fun. And I can go ahead and open one of these up. Open it in Playground. And I can actually chat with this and test if it's going to do what I need it to do. So I'll ask, have you ever seen... I'm doing this spontaneously because you just reminded me of Morons from Outer Space. Movie Morons from Outer Space. Let's see what it says. Okay, well, we can't watch movies. It's a so British science fiction comedy released in 1985. Yeah, it was a while ago. Yeah, so it follows the story of four aliens who crash down on Earth, mistaken for celebrities due to their unusual behavior. What is the how does the spaceship run? Let's see if it has context here. Yeah, so it keeps the context and it's nice. Okay, so small handheld device the aliens carry with them. It's allows them to travel to space. It's not explained in the movie. It's presented as a comedic plot device, yeah, because they don't know how it works. Just like most of us don't actually know all the details of how our car works or anything like that. So it's cool. So I can work with these. You get the idea. So I can come in here, I can test it out, and I can see if it works. And I can play around with this and see if it's going to meet my needs. And then I can go back to OpenAI and or go back to my Azure portal, and I get the keys, and I can set this up and put some code around it and fire it up. So that's basically how you set up models. It's pretty easy. But how do we actually implement something like a RAG that Jennifer was describing? That's pretty easy as well. Let's go back to the dashboard here. There's a couple different ways you can do it. There's a little tool called LangChain, if anyone's familiar with that.
Would you be open to just quickly defining retrieval augmented generation, as because we didn't really quite like get the short version of it. We just kind of dove right into it. Would you mind like taking like 2 seconds to just sort of explain the concept?
Sure. Well, Jennifer covered it pretty well. But basically, in essence, what it is you have ChatGPT or another large language model, which provides mysterious information. Someone asked about provenance. There's no provenance in large language models. There's you just get an answer back. You don't really know where it came from. You don't really have context around that answer. You just hope it is correct, and you have to use your own personal experience to figure that out. So RAG is kind of a way of solving the provenance problem, solving the background problem, and adding data that only your organization or you can see as part of your search. So what happens is the search goes out just like it does to ChatGPT. It goes out, asks a question, receives a response. But in a RAG model, it automatically does a parallel search in your own data from a vector database that Jennifer described. The vector database then retrieves data based on the query, the prompt that you've put together, and adds that data to the response it gets from the large language model. That way you've got some context and you've got what Jennifer and the industry describes as grounding in your model. So it's just a way to provide proprietary information or additional information that needs to be referenced or verified when you're doing the searches and stuff. Hopefully that's helpful.
Thank you. I know Jennifer did it justice. It's kind of new for a lot of us.
Yep.
I think it's
Totally.
great to hear another perspective. So thank you for giving us the short version. Much appreciated.
Sure, no problem at all. LangChain for J is the Java version of LangChain. By the way, just a little trivia, they're not really related, even though they both have the same LangChain name. LangChain for J is a separate product. It's a separate project, and the corporate custodian of that is actually Red Hat. They actually hired the guy who created it recently, and people on my team, including Julien Dubois, my boss, and Sandra Algrim, have contributed to this as well. So LangChain for J is a great way to just add the capabilities of various different large language models in a single interface, plus add retrieval augmented generation built in. And there's also some examples. So LangChain for J examples gives you a ton of examples here. As you can see, all contributed. Hey, there's one. Look at that, Neo4j example. So I wonder if I bet Jennifer had something to do with that. And then we have OpenAI examples, which is what I'm going to show you. Actually, I'm going to show you the Azure OpenAI examples today, but there are OpenAI examples as well. And there is a RAG examples and Spring Boot example as well. Not Spring AI, but Spring Boot example here too. So I won't dwell on that because Jennifer really did justice to Spring, but I will follow the Azure OpenAI examples. And by the way, all you need to do to run the OpenAI examples is change one of the variables in the examples I'm going to show you. All right, so hopefully that sets the stage here. Let's go into Visual Studio Code and we'll start driving the spaceship. All right, here we go. So this is Visual Studio Code. This is GitHub Copilot over here on the right. As I mentioned before, there's different ways you can use it. I can actually ask Copilot something about this code. I can also use a slash menu. And for those of you who are old as dirt like myself, you might remember a slash menu in spreadsheets 100 years ago. If you don't, that's okay. You're young, you have your life ahead of you. It doesn't matter. But the slash menu in spreadsheets used to be how you would bring up the menu so that you could write functions and things like that. And it's coming back. It's coming back in all the UIs that we have for AI. So this is some of the things you can do. I could type in here, what does this code do? Or I could just say explain and spell it right. So what it's going to do is it's going to use a reference. Oh, I'm sorry, but there doesn't seem to be any code provided in the excerpt from the active file. Oh, okay. This is part of the fun of doing live demos.
Sorry, I can't do that, Dave.
Yeah. Yes. This is part of the fun of doing live AI demos. You got to be okay with things not going well. All right. I'm going to make it work though. I shouldn't have to do this actually.
We've seen you get out of tighter spots, Brian. We've seen you get out of much tighter spots. You're fine.
So it's usually, yeah, thanks. It's usually one reference here. The Java code is a simple example of how to use it. As you can see, this is hard to read. So you can go up here. You can just say open chat in editor. And it's going to open up and let you have a look at this. Let's see. The Java code example is how to use the Azure OpenAI chat model class to generate a response to a given prompt. The chat model contains a static inner class simple prompt with a main method. Okay, so the main method calls the chat model, and the builder does the building process. And we have an OpenAI key, an OpenAI endpoint, and I've hard coded this, and I'll explain why in a little bit. So basically, what that does is it lets me run the query, and let's just do that. Here, I get the prompts. I've got some prompts already created. Where are they? Up here. Okay. So this is for the prompt. Hey, I didn't do that. What happened there? See? There we go. So what it's going to do is it's going to go out and it's going to run this code, and it's going to retrieve the results that I've asked it to retrieve. Yeah. So what I asked it, let's go back to the code. Up here in the prompt. So basically, it's just a simple prompt. It uses the OpenAI key endpoint and a model, and it provides 3 short bullet points explaining why Java is awesome. It right here, platform independence. And by the way, these are different every time you ask. It just goes ahead and generates something based on whims. It's whim-based responses, and it gives you an answer. But I can put whatever I want in here. If anybody has any audience recommendations, behave yourselves. But if you want to put 3 paragraphs. Wait, actually, let's say 3 short bullet points on why the San Francisco Java user group is awesome. Let's do that. All right. Whoops. I guess I can do word wrap on this. Probably a good idea. All right. So then I can go ahead and just run this again. Now let's see. And I'll show you something interesting in the response you get as well. Networking opportunities, the Java user group provides a platform, blah, 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 blah. Peter, you probably recognize this from somewhere on the website. Knowledge sharing, organized meetups, community support, user group fosters a strong sense of community, et cetera, et cetera. So that's cool. It's kind of useful the way it does that. And then you can say something like, do this and rewrite it, but in Old English, and it'll do that as well. I'm not going to burden you guys with all that, but you get the idea.
So iambic pentameter. Come on, Brian.
Oh, okay. You want to? We'll do it.
No, I'm just kidding. I'm kidding.
Provide a sonnet.
Exactly. Exactly.
I got to do this now. This is sonnet.
Uh-oh, challenge accepted.
Provide a sonnet on why the San Francisco Java user group is awesome. All right, let's run that.
See, OpenAI wasn't kidding about the camaraderie.
Yes. And I'll show you something by the way. Oh, there we go. Go to San Francisco.
Yeah, I love it. It's great.
It's pretty awesome. So in the city of innovation and tech, you stand out, shining bright, a guiding star. Communities. I'll give you this for a decent price later, Peter. But
thank you. I just want to know what a fleck is, but we'll come back to that later.
Community is always on fleck. This is where we have to talk about hallucinations.
Hallucinations.
That's right. This is not exactly a great example of hallucination, but sometimes you'll just get code that's just absolutely nuts. Anyway, so that's enough of what the code does. Let's see what we can actually do with it now. Let's say, let's go up here. The other thing I can do, instead of having this over here, I can do Control-Shift-I, and I can ask a question right up here. And I can once again fix. So it's going to check and see if there's anything here we need to do. It's going to use this. There's no code provided in your message. Oh, once again, it's supposed to be able to, you read the slide. It's supposed to be able to read this, but you know, it's Wim based.
I'm sorry, you can't do that, Dave.
That's right. That's exactly what's happening here. Okay, so let's go ahead again and say fix. And it might actually find some problems. Sometimes it does. It's kind of annoying. Not that I've ever had an experience like that, but yeah. It's not clear what the exact problem is. The code seems to be correct. Of course it is. Absence of error handling. If the environment variables are correct. Okay. So there you go. So it adds some error handling. So let's see if this works. I can actually take this now and I can add it. Let's go here.
Wow.
Here, there's you can copy this into a terminal, or you can insert it a cursor. So I can insert it into this, or one of the cool ones, and I don't know why they hide it over here, is insert into new file. So I can actually create this new file here. And let's close this and let's call it what did it call it? It didn't call it anything.
Yeah, I don't think you gave it a name.
Model examples. Okay. We don't want to use that one because it's already there. So we'll use GAI. How's that? Let's save it like that. Oops. That's not what I want. Save it. Okay. It's bringing this up. Usually it doesn't. Source main Java. That's right. File name. Save. Okay. So I've had some problems running things today, and this is probably going to error out, but it will give me the command that I need to put into the prompt to do it. Bum, bum,
It's a valiant attempt in any circumstance.
yeah, it errored out. That's okay though. Here, what it's going to do is it's going to give me the code that I need to use. So what happens is the environment variables for some reason aren't being picked up. So what I need to do now is this prompt has the environment variables put in, but it's up here. So now I can just run this. This should work. Fingers crossed. There we go. Yeah, okay. So it provides a sonnet. So you can see it actually added some error handling here. It's got an exception now. It generated another one. Did it still use Fleck? I don't think so. No, it did a new one. So there you go. We got a new sonnet. And we got new code. And that new code can be updated, managed, obviously. Let me see though. There's one other thing. Oh, I want to show you this. So inside of this blob here, so you send it the command, which is provide a sonnet on why the San Francisco Java user group is awesome. And then it takes that prompt and it messes around with it. Let's see. And it actually, oh no, it didn't do it this time. Okay. So it provided a sonnet on why the San Francisco Java user group is awesome. Sometimes if the AI believes that this might somehow be harmful or against Microsoft's AI principles, it will change the prompt or tell you it can't give it to you. So if you look down here, you can see what it checked inside the token. It checked the model session, the body, and it checked for filter results.
Self-harm, violence.
It checks for hate, self-harm, violence, stuff like that. It checks severity of things. It shows safe choices, and it verified that this is a safe query, and it provided us some safe results. I'll show you a better example with DALL-E now. Oh, one other thing I want to show you before we move on to DALL-E. So I can take this code now, and I shouldn't have to do this, but just to be safe, let's do Control All. And let's go Control-Shift-I, and let's say test. This sometimes works. So, but okay, yeah, nope, not today. I'm gonna say no, Mr. ChatGPT. So let's do test again. It should work. Okay. Run. Cannot have a text note outside of chat message text. Oh, thanks so much. Okay. Anyway, that's not going to work. But generally, you can write tests on these things. Let's try this one. Let me close this. Yeah. Why is it here? Oh, this is oh, I guess I could just do it here. No, I can't. No, never mind. Let's close this. Let's start over. Roll Shift I. Tests. Come on. No. It's not gonna do it today. Well, let's try it. I'm still doing this. See what I mean about you can't be afraid of failure.
Nope.
Yeah, it's just this is a weird message. Never mind. Let's move on. I did want to show you how it generates tests, which is actually usually pretty good.
That's a stellar feature, as a matter of fact.
What's that?
That's a stellar feature.
Yes, absolutely.
Absolutely.
It automatically generates tests for you, and then you can just do what I showed you and save as a file and add them to your code, and they 9 times out of 10 work first time. So it's pretty cool stuff. But anyway, I did want to show you the DALL-E as well. Oh, the other thing I want to show you, let's go into show opened editors. Model examples. That's that one. DALL-E example. Okay, so DALL-E example is similar, but it uses the DALL-E image generator, and it provides you with an image. So a set of coffee mugs in San Francisco, California, with San Francisco, California, USA in the background. So this is pretty cool. Let's save this, and let's run that. I need to get my prompt. I'm going to close that. Oh, you know what? I think it's because I already had a chat window open. It was probably confused. But let's do it here. No, still doing it. Okay, I won't try it.
All right. Hey, it's worth a shot.
Yeah, I don't want to waste anyone's time anymore. All right, so in this case, what we're doing is we're doing a similar thing. We're using the OpenAI chat model builder still, but we're using the no, this isn't the one we want to use. This is the one. So we want to use the DALL-E 3 model that I showed you earlier this time, and it's going to do a response for us. And so let me just get that response. All right. This is the manual command for DALL-E. Oh, I can just run it actually. So let me go down here to the terminal. I'll go down here. It's going to run similar thing. It's going to get a sense of coffee mugs with San Francisco, California in the background. Right. And then I'm going to show you something interesting with Duke and why it has this OpenAI thing. So look at the prompt it created this time. It didn't use my prompt. It used a different prompt. I'll explain what that is in a second, but let's look at the picture first, because it's not going to give you images that aren't safe for work. So there you go. Pretty cool. Let's have a look at what that was actually generated. So sweet. I asked it,
I just said, sweet. That's awesome.
Yeah. I asked it here something pretty simple, which is provide a, oh no, I have it right here all the time now. I'm going to close this one now. Okay. DALL-E example. I asked it to provide a set of coffee mugs with San Francisco, California, USA in the background. And that's what it did. But look what it did down here in the prompt. And this is interesting. And it does, provides a little bit of breadcrumbs as to how it's actually working. That's the original prompt right there. Down here, it checks to see if there's anything offensive about the image. And it says a collection of colorful ceramic coffee mugs arranged on a wooden table against the left. It just decided to create this prompt, and it sent this prompt instead. The iconic Golden Gate Bridge and rolling hills are unmistakable, blah, 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 blah. And this is the kind of thing that people do with ChatGPT. They go in and they say, please create a prompt for me that I can use with Midjourney, which is another generation tool for images. And it'll do something like this. It's much more descriptive. And then it actually creates an image in a blob service that you can go out and get. But you can see it's interesting here how it does that. And I can do something in an impressionistic image. Let's do that.
French impressionists. All right.
Let's see what we get.
This ought to be good.
Yeah.
Question from Mega. Hopefully I'm saying your name right. Please forgive me if I didn't. Can you explain why the prompt was changed or revised, Brian?
Yeah. So basically, it's our DALL-E / OpenAI API safety functionality that is being enabled when I do that. So every time you send something through OpenAI, you can turn on and off the safety. The safety itself just prevents any offensive images from coming back. There's been some things in the news from competitors about just weird or offensive images that have been generated from other tools. We've obviously had some experience with that in the past as well at Microsoft, and we have pretty good tools and pretty good developers and teams of folks who make sure that the images are as inoffensive as possible. So there you go. There's an impressionistic image. Now I'll explain that a little bit more. I'll show you the actual thing in action as well. An impressionistic image of a set of coffee mugs in San Francisco. Now, if I want to say with let's say display the Java mascot Duke. Let's see what this does. Yeah, I'll show you this thing. And this is a great example of the kinds of things that the AI will check and tell you it can't be done. And it'll try. It'll give you something like, we can't give you that, but here. You'll see. Open. Not quite. Although it is it's got some of the aspects, but I don't think this would be within the branding parameters for Duke. Yeah, so one of the things you can say is I have copyright permission from owners of the Java mascot Duke to use it in images
Brian, while you're thinking about it, Mega asks another really good question.
Yeah.
Do we, the developers, get any insights into why that was considered offensive?
It wasn't offensive necessarily, but it could be under copyright because the AI model knows enough to know that Java is a commercial product and that Duke is an image that is used in that commercial product.
I think the question behind let's step back from that specific instance.
Yeah.
I think what Mega's getting at is like, do we see the explain plan? You know what I mean?
Okay.
Like, do we like, developers they're always going to want to know, hey, if I gave input X, I got output Y, what tripped the flag?
Yes. Yeah.
So do we get the explain plan? Do we know why? Is there some way to get feedback in terms of like, well, wait a second, hold on. Oops, I stepped over the boundary. I didn't mean to, maybe, but where did I?
Yes. So that's a good question. Yes, you're right. That is a fantastic question. Thank you for asking that. So here I can take this prompt. Let's go back to what I showed you earlier. There was a method to my methods. Where is it? Inside of here.
The impressionist one is awesome. I love it.
Yeah, it is pretty nice. If I go to model deployments here, manage deployments. So this is why one of the reasons why I showed you this was because you can interact with the model here and you can ask it questions. So you can basically see why did you do this? Okay. So it's going to generate it. Let's see what it does. Bum, bum, bum. Okay. So the problem here, obviously, is it doesn't like to use and then you ask the question, can I use the Java mascot Duke in images with this model? And this actually may or may not work.
Given Sun Microsystems layer fleet, I'm guessing no.
But
like one of Matt Rabel's videos on the YouTube channel got DRM'd because he even mentioned Star Wars.
Oh wow, look at this. So up here on the right, it says your request was rejected as a result of our safety. Wait, I'll do it again. Probably going to get kicked out of here soon. There it is. Your request is rejected as a result of our safety system. Your prompt may contain text that is not allowed by our safety system. And then there's an ID. Unfortunately, it doesn't do it. But I can switch to my other model and I can ask there. And this is interesting when you do this because where's my models? Deployments, there it is. So when I open this in the playground, so using images, I want to create a mascot Duke. I want to create an impressionistic image of a set of coffee mugs displaying the Java mascot Duke. Is that possible to generate with the three? And this is fun because I chose 3.5. It's going to tell me, yeah, it does not have the ability to directly access copyrighted materials. So there you go. There's your explanation provided by AI. I'll make it a little bigger there for the folks.
Fantastic. That's good.
Yeah,
that's
so
good.
as a Angular AI language model can provide guidance, but I cannot directly generate or create images. DALL-E is an AI model that generates images from textual description. It can't use copyrighted materials. hire a graphic designer or an image editing software like Adobe Photoshop. So there's your answer. Basically, it's just preventing that from their safety system. In DALL-E, it just tells you it's not safe query. That doesn't mean it's unsafe. It just means that it can't answer. And then if you come in here, it'll actually answer it for you. So once again, it's kind of a handy way to do it. But
Pleasant surprise. I wasn't expecting an answer and an explain. That's
yeah,
cool. That's
yeah,
really great. I think that's super helpful. Because otherwise, like as a developer, it's not deterministic suddenly, and you're like, wait, what? This is a weird black box, and I don't know how to work with it. Help.
yeah, yeah. And so the other thing I wanted to show you is you can do things like, it'll automatically add code down here. Automatically add code down here. No, it thinks that one is complete, so that's fine. Good. But I can add something here, like, let me see. Come on, do something. No, usually it just completely helpfully adds things. For example, if you go here, yeah, so you can add temperature. This is the old school Copilot without the chat, but it automatically adds things for you if you want to. You don't have to, obviously, but you can add other things. It'll choose the deployment name, things like that. It just speeds up your code really, really a lot and allows you to interact with these things. So that's kind of what I wanted to show you today. Let me go back to the portal and see if there's anything else I wanted to cover.
You're 15 minutes over, but remarkably few people have left the Zoom.
Okay. Well,
no. That was not a shepherd's poll. That was not a shepherd's poll. Remarkably few people have left the Zoom. So you as always are crushing it. Just yeah.
Thanks for hanging in there, guys. I'll just go through this real quick, which is basically we've been working with AI for a long time, and we have AI principles. So what you saw in action there is our principles for privacy and security, inclusiveness, accountability, transparency, fairness, reliability, and safety. And we put that into all our tools, including our OpenAI tools. So you can turn that off. You can turn off the safety, but you have to make an exception to do that. And here's the AI principles that we live by at Microsoft. And these have been developed since our original timeline you saw there was 2016. So it must maximize efficiencies without destroying the dignity of people, must guard against bias, it needs accountability so we don't do unintended harm. AI must be transparent and it must be designed for intelligent privacy and it must be designed to assist humanity. So those are our principles. Just want to mention JD again, and I do have some links. So I'll share these links in the chat as well. But I can go ahead and take questions now if you want. That's a good segue though. I'm glad you mentioned time. I was just having fun there, and hopefully everyone else was.
Not at all. That was fantastic. That was a pleasant surprise to see the explain. Wasn't expecting that. That's great.
I'll put it in the chat.
Thank you, Mega. Again, I hope it's the same. I'm really pretty sure I'm saying your name wrong. So thank you for asking that. I think that was great. Hold on, we got a comment here coming in. Sean basically saying, "Hey, I use GitHub Copilot for my open." Oh, you see it? Okay, cool. Yep.
Yeah, it's great for helping write documentation. Yes, they used to have a /doc as well. For some reason, it's gone. I don't know. It changes daily. But the doc thing was very, very cool. It still does things. You can say, you can go in and you can say, you used to be able to say slash or control I /doc. God, doc. It's getting late. Doc, and it would actually add a little documentation here. Maybe it will. Maybe it still works. It's not documented though. Hey, the doc is no longer documented. Isn't it hilarious? There it is. So you can do things like that. You can accept it. So it just says this class demonstrates the usage, blah, 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 blah. Or you can select the whole thing and control I, doc. Yeah, it still works. It's not part of if you hit the slash menu though, it's not there. That's funny. So there you go. It's added all this for me. I'll accept it all, or I can rewrite it all. This is a huge time saver. As much as we all love doing documentation and tests, the tests and doc in this thing is really, really handy. So just helps you, meet those requirements if you're working with folks who need the documentation. Yeah, somebody said as well, the explain is pretty good for closure. Yes, it is. The main thing that this is good for, I showed you all Java today, but I'm presuming that a lot of people here in the Java user group already know Java. So what it's really, really useful for is things you're maybe not familiar with. It's like when I do a deployment to Kubernetes, I just say, how do you deploy this to Kubernetes? And it goes, oh, okay, well, this is the file. This is okay, build this Docker file. And then here's a deployment manifest. Do you want a service? Oh, here's a service. And you basically just literally copy the YAML into your local file. And then you can just do a kube control deploy. And it generally works the first time, which is not the way.
Lies. I don't believe any of this, Brian. I don't believe it. No, this is too good to be true. I don't believe it.
Yeah, it's true. It's how it works, man. Let me show you this. I'll show you actually.
That's incredible.
How do I create a Docker container from this? Because I typed form, so you need to create a Docker file. Here's a step-by-step guide. It tells you how to do it, and then it gives you a Docker file, which is nice. Yeah, and this is like saves you a massive amount of time. They can say Docker build, Docker deploy. Great. So then I can take this and I can insert it into a new file, and I can save that as a Docker file if I want to, or I can continue and say, how do I deploy this to Kubernetes? Okay, Kubernetes deployment YAML. Okay, my Java app deployment. Yeah, so basically it gives you the YAML. That's a pretty generic one, but oh, and there's a service. Yeah, so it access from the internet is service. So here it is. Then it has a command for setting that up. So I can just once again create a new file with this, create a new file with this, and then try and deploy it to Kubernetes. So anyway, I digress. Hopefully that's useful. I find this is where it really shines for me. The Java stuff is useful, but this is really saves me a ton of time. I don't have to, normally I'd have to figure this out online, but yeah. Who wants to? So Jennifer, yes, who wants to write a bunch of YAML? By the way, Jennifer, feel free to jump in case there's any questions for you or anything. If you're still around, that's fine.
No, she's clearly around. Sorry, that's why I'm like joking around with saying lies, because I mean, gosh, this is incredibly helpful. Like,
yeah.
Like I literally just wasted like multiple hours of my life on this last week.
Yeah, this is
like I'm not even kidding.
Oh, I know. It's like that one space in your YAML file. These ones don't have the space. These are generated and they generally work the first try, which is mine never do when I hand code them. So yeah, it's pretty cool.
All right, folks. Really appreciate everyone staying on a bit late. Brian, what a great testament to your just as always amazing content. I mean, how many times have I told you this? I guess I'll have to say it again. Thank you so much for being here and sharing this with us. I think it's great.
And thanks to Jennifer. Jennifer's back. Thanks for setting up. Thanks for teeing everything up for me. That was great.
That was. You guys are a powerhouse duo, and all I can say, Jennifer, is wow, I should have had you on San Francisco Jog a long time ago. My bad. I will rectify that error in future months. Sandy asks, is GitHub Copilot available in IntelliJ?
Copilot is. Copilot Chat is still not available, but it will be soon. I can't tell you more than that, but yeah, it will be soon. So Copilot's there, but not Chat yet. Yeah.
Okay. All right.
Yeah. And yes, it is license based. Individual license is $10 a month. There's an enterprise. If folks already have GitHub Enterprise as part of their work, you probably already have it. You just didn't know it. I find a lot of people don't know that. They already have it. They're just like, oh God, I just need to sign in and it works. But yeah, that's one of the secret one of the sleeper features is definitely.
Corporate license agreements for the win, people. Yes, absolutely. Okay. All right, folks, last call for questions. An epic 25 minutes over like scheduled to end time. Clearly awesome content. You two are amazing. This is great. Yeah, some companies have already secretly signed you up. Exactly. Um, uh, Fantastic. What a wonderful evening. Thank you both. I can't remember a more engaged. Personally, this is just a fun topic for me. I've been wanting to learn a lot more about this, not only from the Azure side, but also to be completely honest, just because I've not personally made a study of graph databases. I really wanted to see how graph and AI came together. So Jennifer, thank you for that so much. That was a really nice insight that you brought today. So uh, cool. This is going to get posted to our YouTube channel. I will send it out to all attendees on the Meetup channel. And boy, would we like to have both of you back. What a wonderful tag team. Um, Absolutely. All right. This is literally your last chance for questions, folks. If not, I think we're going to call it and have a wonderful evening. Please stay safe. We've got a couple of other events coming up on the meetup. If you, like I said, if you go to meetup.com, SF Java, I will drop the URL real quick here in the Zoom chat. If I can get back to my Zoom controls. There we go. So please have a look at that. I found something disturbing about meetup.com. If you don't show up there once in a while, you get suppressed from
Oh,
communications. Interesting. So just I don't know, visit the page every once in a while just to make sure if you like this kind of content, you want more, just visit the meetup page every once in a while to make sure that you still in fact will get emails that we try to send you. LOL. And have a wonderful evening. Thank you, everyone. Stay safe, be well, and Jennifer, Brian, thank you so much for being with us tonight. You guys rock.
Thanks for
thanks.
having me.
Take care. Bye.
See ya.